routing. I will just go through it again very quickly, then we go into the remaining topics of this very important technology. Okay, so routing, as we've seen before, in a single page application, SPA application, which AngularJS is a really excellent framework to implement such architecture. When we have a single page application, we have one shell page that gets loaded fully at the start. And this shell page typically will have some menu items or some menus that users will click. And as they navigate through different links in your shell page, different components get loaded into the shell page. So traditionally, the routing is decided and done by the server in traditional MVC architecture. But in SPA, the actual routing or deciding for a path, for a URL basically, for a URL, which components correspond to that URL, this is done at the client side. So that's why a framework like Angular has a router component that will allow us to associate a URL with a component. And dynamically, the system will load into the page the appropriate component based on the user action. That is the idea. So, so what this allows us to do, it allows us to avoid full page refresh. We never load the full page again. We only load full page for the shell page, which is the first initial page. After that, we only load components into the shell. So to do this, that's the basic idea. On a URL change, when the URL changes, we want to load a particular component. And we don't want to do this programmatically, a lot of coding, a lot of kind of a switch statement or if else. If the user clicks this, then load this. We don't want to do this programmatically, although you can. The Angular tries to be as declarative as possible, as declarative as it can. So to be able to do this, Angular comes with a very powerful router component. And this router component has 4 major elements. The first one is called the router outlet. This is basically a directive, a tag that you put on your page, and that's where the components will be loaded. So the outlet is where the components get loaded. Second element of this router component is the router config. This is declaratively you specify for this URL, this is the components corresponding to it. And for URL 2, this is the components corresponding to it. And then we have a router param, which is a service that allows the component to read the parameters passed in the URL. You know, URLs sometimes have parameters. So when the components get loaded, we want the components to be able to read the parameters from the URL. Even in your homework too, we kind of read in some parameters from the URL, but it's not very elegant. We're doing it imperatively by coding ourselves. Okay? And then finally, the router link is a way of creating links on your page and referring to the routes that are defined in the router config. So this will become clear as we go, but there are basically we have a router component in Angular, and this router component provides 4 elements. Each element has a specific role, as we will see in more details. Okay, so here are the steps. If you want to make use of this router component that comes with Angular 2, this is what you need to do. First of all, you know, Angular is very, very modular. Angular framework itself is modular, is made up of clear components that you import if you need them. If you don't need them, don't import them. And also, it kind of encourages us to make our application that we build also modular. So modularity is one of the key design principles in Angular. So that's why we have this router directives that comes in this file called Angular2. So this router directive has this annotation called the router config. Remember, yes, please.
Sorry for interrupting. Can you double check this information?
Yes.
Because I think it's on the /route, not /Angular2.
Not /Angular2, yes, thank you. I will check right now. Let me see. Okay, I have an example here. All right. Let me
Yes, at the top.
on the top. Router, yes, router config, yes, thank you very much. Yeah, you're right. Okay, so thank you. Okay, let me just fix this quickly. Oh, sorry. Alright, so I'll just call it a router وخلاص. Alright, here it is. Thank you. Yes, so this directive lives in this Angular2/router module that comes with Angular. So what you do is, remember that, just to remind you, an Angular app is made up of components. Each component defines the UI and the behave that controls the user interface or the UI. And also, you can come to a component, typically the root component, and you can add this route configuration. For example, in here, when somebody comes to /, which is the root of the application, which component will be loaded when the user goes to this URL? This is the app component. And here, this is just an alias or a name. We give this route or this path, we give it a name. What is the name of this path? Home. You can call it whatever you want. So when we are defining links later on, we will refer to this name, not to this URL, because the URL more likely to change, and it might be kind of nested or has levels, and it's kind of a bit harder to refer to. So instead, we name our routes. So when we refer to them later on, we will refer to them by name. That's why this is very important. So each route in my router config has a name. How do I specify the name? By providing an as a property in my objects. So you can see this router config is nothing but an array of objects, and these are JSON objects. So each route has how many properties? 3. The path, the component corresponding to that path, and a name. Okay? So, and for you to use this directive, this annotation, what do you need to import? You need to import a router directive from Angular2router, and you also need you know how components has one of the properties of the components annotation is directives. You have to tell Angular that you need to use this route directive. So let me show you the whole thing in a concrete way. Here it is. So in this component that is called app component, I want to define a routes. Where are the routes? Sorry, maybe not in here. Okay. Yes, here, sorry, here are the routes. Yep, here are the routes. So I have a component here called root component. This is the component that will get loaded the first time you launch your application. And in this component, you remember that a component is nothing but a class with the annotation component. And the component provides like this three important properties. The first one is the selector. This is where the components will be loaded. The template, this is the HTML template associated with the component. And directives, here we're declaring the dependencies on which this component relies on. So this component, for it to work, it relies on other components and other directives, and we list them in the property called directives. Here it could be built-in components that come, or directives that come with Angular, or our own components. Okay. So we come to our root component and we define this route config. So this declaratively specify for each URL what is the corresponding component. Okay. Now, the second thing I want to show you is this is the root component. It does nothing. The root component does nothing except it shows two links. How many links? 1, 2, 3. 3 links. Okay. And a router outlet. So first of all, let's start with this simple one, a router outlet. What is the router outlet? What is the role of having this tag? Yes.
When the route achieves, so if we go like /heroes.
/heroes, yes, thank you.
Yeah.
If someone goes to /heroes.
Yeah, the value that was supposed to go to the selector of the component will go under the outlet.
Yes. So if somebody went to this URL, goes to this URL /hero, then this component will be loaded. It's called the hero form component. But where it will be loaded? In this location, in the router outlet. If somebody goes to /router, what will happen? This component will be loaded. It's called the router example root component. And where it will be loaded? In the router outlet. Okay? Now, this root component is basically the shell page. Usually, on the page, typically in most applications, you will have some menu here. Typically like on maybe horizontal or vertical. And that menu, in most cases, does not change. It stays the same. And this is what this root component is trying to do. It loads itself, and all it does, it just creates the menus. And also it defines the route. It says if the user goes to this link, if they click this link, this is the component I want to load in the kind of the main part of the page, or the main content of the page. If the user clicks this link, this is the component I want to load. So you declaratively specify this, and this is very, very useful. Without any coding, the Angular takes care of this.
The class is empty, so we still need to define the class, or
which class? Here, okay, very good. In here, this is a proof that the Angular is the one that will do the magic of loading the component into the router outlet. So you can see here this component, this root component, does not provide any data to the component. And it does not handle any behavior. That's why it is empty. But maybe in real life, you might have another page where the user logs in. And based on the login, they will get different privileges, which means they will see different menu items. In such scenario, you might have some, like this one, you provide the menu items that you display in here. Okay? So, but in here we are hard coding the menu items. and we're assuming the user who lucky user comes to this page, to this application, they will be able to see all menu items. But in here there is no logic. The root component, what is the role of the root component? It just shows the menu. And it defines the routes, which means for each path, or each link, what is the corresponding component that should be loaded. So when, let me just try to comment this, or make it let me just try to comment this one. And see what will happen. Okay, so what I did here, I just commented the slash, the root, which means if somebody goes to the root, they will see nothing but the menu. They will only see the menu. So hopefully, if I try to run this, okay, I think I kind of discovered this. There is a terminal already built in WebStorm. Yeah, I can do here arrows 2. What was the command? Here is the pack. Is it? Yes, npm start. Did I need to do the npm t? No, I think, sorry. It automatically does it? Yes.
Yeah, because you're using WebStorm. It does the transfer.
If you say so, if you configure it to do so. So let me, let me just, okay, let me just be on the safe side, and I will just, okay, let me, sorry, if you don't mind. Show in Explorer. Just do it the safe way. Go get bash here, and then npm type tsc TypeScript compiler. This will watch for any changes. Sorry. Okay. ts npm. Run tm. Okay, tsc. Okay, thank you. So this window will keep watching if I do any changes, it will recompile. So here, let me just those of you who are still a little bit confused about this, for the TypeScript files that are in your project, you have two solutions. Either you configure Node.js. Sorry, you configure WebStorm to compile them for you, or you run the compiler in the command line to watch for a particular folder, and if there is any change to that folder, it will recompile. Okay, so in this scenario, at least, since I started it this way, I'll continue this way so it doesn't break in the middle, at least in this during the session. So I am starting the compiler outside in a separate shell or a separate command line. Basically, to do so, I did npm run tsc, which stands for TypeScript compiler. Now, this one I cannot use this anymore because it's still running and keep watching that folder. As you can see here, this is the folder it will watch. src, the source folder, and this is the kind of the flag we pass to the compiler to keep watching. Now, I will go there again and open another one. Sorry, where is it? Yep. I'll open another one, and this time I will run it. Git bash here, and what is npm start, is it? Okay, this will take our application, deploy it into this live server, a little live server, web server, and then launch it. So as you can see here, what happened? Okay. No, I know what's going on. I know. No problem. Let me explain it. I should have separated into examples. I didn't do so yet. So, sorry? No, it's not that. This is something different. I will explain it. Just give me 1 second. Okay, here it is. Let me go back to my app. And as you saw here, I commented this, but this is not what's going on. Okay. As you can see, when the application starts, this is not the component that gets loaded into the shell page. How do we decide which component to load in the shell page? By calling this function get, called get bootstrap. This is different than the CSS bootstrap. This is just a function that you kind of tell Angular what is the root component, which component will be loaded when your application starts. So in here I have two applications in one. It's just laziness of creating another project, but I will be separating them shortly. But let me show you the other component that is currently loaded, which is, yes, thank you. Route example, yes, thank you. Here it is. So when my application starts, it is the route example root component that get launched. So let me explain. This one is very simple. That's why I will start with it and then I'll go back to the hero example. Forget about anything about the hero example. These are two in one. I will separate them, not to confuse you. So let me go back here. This is my root HTML page. Okay. This is the only page that is a full page, which means this is the only page that has HTML, head, and body. This is the only page in my entire application. That's why we call it single page application. This is the only single full page. And this is the only page that loads all the dependencies that we need. All the third-party frameworks and libraries that we need, they are all loaded here. Then we use this system.js. You see here, we use this system.js to load our router example component. So we have an example component. In here we have two major components. One is the hero component. It's called app. Another component, it's called a router example. Usually we will only import the root component. And from there, the root will know how to import the remaining component. So let me just summarize. This is very important. So the shell page, or the root page, whatever you want to call it, we have only one that has the full HTML page with the head and the body. Okay. In the head, of course, I will put all my dependencies, all the CSS files that I depend on, all the third-party AngularJS or all other JavaScript libraries that I depend on. And also, I must include this system.js, which is a third-party library that is able to import modules. So remember, the concept, the feature of modules is a new feature in ES 2015. And the browsers are not yet able to deal with modules. So that's why we put in this third-party library called system.js. Until such time, browsers catch up and they will be able to deal with modules directly. Okay? Then, the system.js, what we tell it, we tell system.js, please, whenever I tell you, please import this or import that, I'm not going to tell you the extension. by default the extension will be JS. And then in here I only load the roots. Usually you will only find one entry. It's because I have two examples in this same application. I import in two. But I can, not to confuse you, I can make it like this. What is the JavaScript comment? Sorry?
You can just write control.
Okay. But if I do like this, it gets commented properly. No? Anyway.
It's fine.
It's fine? Okay. So it is the IDE bug, kind of. Okay. So it is clear what's the role of this shell page, and we only load the root component. Okay. In here, as you can see, I have a placeholder called Heroes app, and this is where the root component will be loaded. So in my case, if I go to this router example, have a look. Here is the router example. In the router example, I have, okay, in the router example, I have a root component. Okay, very good. Here it is. Okay, in the router example, I have a root component, which is called router example root component. A very innovative name. This is an empty class because it doesn't do anything. It will only show a menu. To make this a component, as I explained, I come and add the annotation add component. And this annotation specifies three things. First, where this component will be loaded when the application starts. Second, what is the HTML associated with this component. And the third, what are AngularJS or your own module or your own component that this component depends on, the dependencies. Is components clear? Then I go ahead and specify the routes. So in here you can see I have two routes in this application. If somebody goes to the slash, which component will be loaded? The home component. And what is the name of this route? Home. If somebody goes to slash product slash some particular ID. So you can, by the way, you can pass parameters to URLs either by putting a question mark and a key equal value. This is kind of the traditional way of doing it. And more fashionable URLs, you just put slash and the value without the key. So in here, that's what I'm doing. If I can do product 1, 2, 3, which means I want to get product 1, 2, 3. So in such scenario, which components will be loaded? The product details. And what is the name of this route? Product details. Product detail, okay? In here, don't worry too much about this. Here I'm just passing some extra information with this kind of, here I'm hard coding this information. I'm passing extra information when the user clicks the link. It's not important at this stage. What is important is, what is the path? What is the component that gets loaded when the user clicks that path? And what is the name of this route? Is clear? Now, in the menu, the way I build the menu is instead of doing the conventional ahref equals some URL. Instead of doing this, I am constructing the route dynamically. The reason why I am not putting the URL here directly is that I want to centralize all the URLs in one place and give them a name. If I change my mind in the URLs, I go to one place and change it. Okay, that's the idea. So In here, instead of using href, I am asking kind of create an href for me based on the route called home. So it will go down here. Let me just collapse this. It will go down here and say, oh, you're talking about the route home. So the href of this link will be /. Are you following? Now, I have another route, which is I want the URL to be product details. I go and say, oh, the product details is this route, which is the product. Now, this route expects one parameter. If you want to construct this route, we need to know what is the ID that you will be looking for. And here I am going and passing this ID as an object. Okay, so this 1, 2, 3, 4 will become, so what is the href of this link? Product / 1, 2, 3, 4. Yes, please, you had a question.
We will be providing it like an array with the square brackets and we can put multiple objects or something.
Okay, here it is. So to construct the links of the menu, instead of using href, what do you use? A router link. And then you assign to this router link an array. What is the first element of the array? The name of the route, not a URL. The name of the route. Very important. Because when you are designing your application, there is more, those of you who have experience with this, there is more likely chances for you to change the URLs. But the name, you just stick to the same name. Home will always be home. But maybe it might be /home or /index or maybe. Here /product could be /p or /prod or you might want to change it. But this one, the name, less likely to change because this one is visible. Maybe the users, they don't like this URL structure that you came up with. You might change it. But this is less likely to change compared to this. And the idea is you don't want to define your URLs in multiple places. You define it in one place, which is the route config, and then you refer to them when you are defining your links on the page using the router link. And the router link, what do? You give it an array. What is the first element of the array? The name of the route. The second element is an object. Is an object that has the parameters that will be used to construct the full route. Are you following? So for example, remember those actions you have in your homework? So for example, each action you have an edit or edit beside it. So in there you will do star ng4, okay? And then inside that link, the way you will generate it using a router link, and you will pass this ID equal the action ID. Okay? So this is basically how you construct a route. By passing an object in the array that you assign to the router link.
Why you use this method in the actions, to edit the actions?
So sorry, can you say?
Why we pass the action ID to edit the action? Why we use ng4?
Okay. If you recall in your homework, when you go to a particular student, you will see the actions of that related to that student. And you can either delete it or you can update it. So there is a link in there. Okay? Yes, there is a link. And that link, when you click it, the link is self-contained. When you click it, the destination the destination component will receive the ID that you want to edit. You follow it? So some of you maybe did not have the ID in the link. They try to read it from the first element, first cell of the row. That is kind of okay, but a lot of imperative coding. In here, it's all declarative. By the way, this ID will be passed to the component called product details component. You will get that ID. And you can basically maybe go and get the action where the ID is equal to the ID passed, and then you show it on the view. You get the idea? Okay. So far we have seen 3 elements the router has. The first is this route config. What do we use this annotation for? To define our routes and give them a name. The second element that comes with the router module is the ability to create links using the router link directive. And the third is this router outlet. And what is the role of this router outlet? This is where the components will be loaded when we change the route, or when the user clicks a different route. Okay? Now, sorry, which in?
The router
initial value, you mean?
the first page, if it has components.
Okay. So usually, this is the kind of the emerging or the common practice. You have a shell page. Okay, you follow it? You have a shell page. And then you have the root component. Usually the root component defines the menu. Because usually, once you load the application, the menu remains the same. Once you load the menu, typically the first route in your route config is the slash, which means the root of your application. So, by default, when your application loads, the root components will get loaded into the shell page. And because the URL is slash, this component will be loaded automatically. So you don't need to here, modularity is very, very important. It's all modular. And you try not to link things by calling each other. You try to do it as declarative as possible. So in here, magically, your root components will be loaded, and the home page components will be loaded automatically.
So,
yes, please.
This is assuming the menu is the first thing in the page. Imagine we want to have, for example, a header.
Yeah, no problem. No problem. Here is your template.
In the root?
Yes. It's better to define it in the root component. Here is you have templates. Do whatever you wish. Header, advertising, whatever you want.
We'll have the header, and every shell page will have.
No, shell page keep it 0, nothing in it. Shell page has nothing. It has HTML, head, body, and one tag to load the root component. Have a look. Even in a real application, very, very complex application, this is what the shell page should look like. Nothing more than this. Okay.
So do we define the footer also in the root component?
Yes.
So we can define a header and the footer.
Yes.
And the router.
And the router outlet. Very good. Thank you very much. And by the way, the header could be another component, and the footer could be another component.
You can inject them.
Yes, you can inject them very easily. I will show you some examples. So really, it's very, very important to keep it as modular as you can. And the shell page should be really empty. The role of the shell page is to load the dependency, the libraries that you depend on, and to load the initial root component. And that's it. From that time onward, the router in the router, here it is, the router in the root component will take care of loading other components. That is the idea. To keep it really modular. And if you want to change your root component, all you do is you go to boot. Imagine you have multiple root components. Maybe the root component is very, very different based on the user. You might load different root components if you wish. Okay, but anyway, sorry, just one thing. Like this bootstrap, this is a function that comes with Angular, to specify what is when the application launch, which component will be loaded. So you specify, you see here, the router example root component is the one that will be loaded. Yes, please. Somebody has a question. Yes, please.
Sorry for the router outlet. Now,
Yep.
in our case, we have the menu on the up. And then if you want to write some HTML code, the menu goes down or something.
Sorry, I didn't know what you were talking about. Sorry. Here is my menu. What do you want to do?
This is our menu.
Okay.
If you write some codes
Above it?
yeah,
Yes, no problem.
that means the menu will come on the...
Here, as what you see, what you get. Here is your template. You decide what you want. Here, for example, I put here H1. Yes. And I'll say here, welcome to router example. No problem. If you want to put something underneath here, before here, you can. Let's say H2. Although the users don't like.
So the menu in this case will come under the...
Sorry?
The menu in this case...
Yes, yes. It is you. You are crafting how you want your page to be. This is basically an HTML. There is nothing magic here. This is your HTML. If it gets too big, you can put it on a separate page, call it an HTML page, and change it from template to template URL. Okay? So this is HTML. It's up to you how you want to make the look and feel of your page.
So at the start, the root component will be loaded.
Yes.
After that, the home component will be loaded.
Yes.
So the home component will override or will take a section.
Oh, very good. It will be on the router outlet. Not after or before. It's up to you. If some reason, maybe you want to be innovative and something different than others, you want to put the menu down. It's up to you. The root component will be loaded where you put the router outlet tag. It's up to you. You want to put it between two menus, it is up to you. Basically, the router outlet is the place where the component will be loaded. So you have control where you want to put it.
And all the components that we load from the router, from the menu, will be loaded in the router.
Yes, in the router outlet, yes. The previous components will kind of go and be replaced.
So if we want some kind of sub-menu process, for example,
So if we want sub-menu, okay?
or like a secondary menu.
Yeah.
So we will have another outlet in the another component.
Yes, very good, yes. Here this is very good question. Here we only see, it's a bit overwhelming already, but we only see the very basic. So the router is very, very powerful component. And by the way, it took many, many years before it comes to this maturity, because they have many other attempts before. So in here we have child routes. Here are the main routes. You can have child routes where you have component, and when that component loads, it has its own menu. And that component will have a router outlet and it will have its own route configs. So the root component might have its route and router outlet, and the child might have its route and router outlet. And there might be some communication between the two. So there is a support for this child routes. So I provided in the slides, the last slide I provided the Angular team slide and a video presentation for those of you who want to go deeper. But in here, let's just focus on the main idea. And once you understand it and practice it, like doing the child route is very simple as well. It's not, the main thing is that you get this right. Is clear so far?
Yes,
Oh.
sorry,
Yeah.
using the route card for what? For the sub-menu?
Okay, I will explain it. Okay, no problem. Let me explain it. What did I say? Okay. Okay. So, for example, although in your homework you might not need to use child routes. So, for example, in your homework, when you have a couple of, maybe, I'm just thinking loud, it's up to you how you will design it. Maybe you will have the login, one component, maybe. The students, it looks like one component. And the actions, they also look like one component, isn't it? So now, when you load the action, that is a component. But that component has its own routes. It has the edit and the add. Okay? And these are different routes. And in Angular, there is another one called auxiliary routes. These routes, for example, if you want to do pop-up menus, that pop-up forms, they don't belong to any component. You can do that as well. So, sorry, let me go back to here. So, some component that you load might have their own routes and their own menus. And you, instead of managing the whole routing in the root component, you can, the sub-components can also have their own routes and their own menus. But this is a little bit more advanced. Don't worry too much about it. But realistically, in a real application, you will find this scenario, definitely, where the sub-components have their own routes. Even if you want to manage it in the root route, in the root component, it's not the best practice. Because remember, components should be self-contained and quite independent. You should not create dependencies. As much as possible, they should be kind of isolated. You can run them by themselves. And then you compose your application from these components. Okay? That is the idea. All right. So let me just run it again just to show you. So hopefully if I refresh this, since I think I changed something, you see, I put that header there, welcome to the route. It came first, then the menu came. Now as you see here, this is pointing to the slash, which is the root. And this one is pointing to product 1, 2, 3, 4. Can you see here the links has been constructed properly? And when I click home, I am in the home component. When I click product details, I am in the product details component. And the product details, as you can see here, it knew what is the parameter that was passed to it. And it didn't do what we did in your homework to go into the URL and then try to slice it and then pick up the parameter and do a lot of coding for it. In here, it's more elegant way of doing it. So let me show you. Sorry, it's not this. No. Let me just close this guy. Okay. Here is my product home component is very straightforward. Sorry, in my home component. My home component is very straightforward. It doesn't need this. It doesn't matter. You can even remove this, no problem. If you don't like it, you can remove it. It has no value in this case because it is the router who is loading this. So no need for it. In here, all it does, it is showing this header 1. And here I have provided here a class called home. Now class, this is a CSS class to make this background red. Now I didn't want to pollute my main component or my shell page with this style. So I can provide a style that is specific to this component. So there is another URL here, another parameter here called styles, where I specify style that is specific to this component. Just for your information. Yeah. And there is style URL. If you have a long one, you can put style URL and put the style. Yes. Yes. Both. In here, if this becomes big, you can put style, template URL. If this becomes big, you can put also styles URL, and you can specify the styles. Yes, please.
In our home work and our project, we will have many components and services also.
Services, we will see the service concept.
So how do we kind of have a folder structure?
Okay. In terms of structure, usually what I have seen so far, like the best practices are still kind of emerging, but usually under source, you will have two subfolders: components and services.
In the source or in the app?
No, in the source, without app. You have one app. Or you can, if you want, the way I've seen most people doing it, now under app, why is it under app? Do we need? Anyway, it could be, but if you want to really be more organized, you can have two subfolders, at least for now. You have subfolder, let's say, components, and another subfolder, services. And for components, I have seen people putting each component in its own subfolder. If you wish.
And for the view use for templates?
Well, the recommended way is to keep the template with the component, not to have. So as I said, the component is self-contained. Anything to do with that component is in one place. So instead of having like a partial subfolder or something, you keep anything related to that component together. It would be a page, but in the same folder as the component, as the TS file.
As the TS file.
No, what I mean is, let's say you have home. Instead of the here, I call it home.html. So in here, similar to this, I will have something called. Sorry. Here is the TS file and here is the HTML file on the same folder. Yeah. So to summarize, for organization, for now at least, if you wish, it's not really, this becomes very useful when the application starts growing. So to keep things organized, you can have a subfolder component where you place your components, including the HTML for that component. And you have another file, another folder called services. This is where you put your logic, your business logic, your computation logic. I will explain what services mean shortly.
For example, for app with given component,
The
the app folder will be one of the components, or we can just start with our own component or root component folder.
You can have. Now, usually the shell page is outside, as you can see here. Usually the shell page outside, and the rest you can have. If your application is kind of simple, you can just have components. All the components are under one folder. If it gets more complicated, each component can have its own subfolder. So you have to balance between the depth of the hierarchy of your subfolders with the complexity. If it is useful, you can add it. But at least I think having components and services will kind of help a little bit. And sorry, there is another one called model. Another folder called model. This is where you put your entity classes. Basically the classes that you define. For example, action, student.
The classes we are basically using with the component.
Yes, the classes are shared. They can be used in services, they can be used in components. Yes. So you define them because the entities are typically shared across all the components.
So we have, for example, the root component class.
Yeah.
So we don't need that class basically because we're not defining anything inside.
No, but you need it because it has you are defining on it the routes and defining on it the menu. Although it does not have any business logic.
We will be having it in a different file, in a different folder, models folder, the root component.
You can have it in a separate folder, or you can have it in a separate folder, yes, if you wish. All other components can be in their own separate folders, except the roots, which is just under components. So it depends how you want to organize it. Yeah. Okay, so this is the root component, sorry, the home component is very clear. I don't think it has much. Now the other one is the product component. So, the product details. In the product details, as you can see here, I'm getting the product ID and displaying it in the template. And this is the double curly brace for the one-way binding that we explained last time. And here is the style. I want the background to be cropped. Now, in the class, there is a couple of interesting things going on. First of all, I declare this property called product ID, so it will be accessible in the template. So if I want something to be visible in the template, I have to declare it at the class level. Second, a couple of interesting things are going on here. I have these two built-in classes. One is called route params, and one is called route data. These are classes that come with Angular, and they are auto-injected. If you want them, ask Angular to give them to you. Okay? So how do you ask Angular to give you some objects at runtime? Just declare them in the constructor and give them a type. And this is what we mean by dependency injection. If you remember, we kind of discussed it a little bit. This is a major feature in Angular, and many other frameworks, but Angular as an example, where you don't create objects that you need yourself. Just ask for them, and the framework will give you an object at a runtime. You don't create them. So, and this is called dependency injection. I depend on, for this component to do its work, it needs the router param. Sorry, the route params. What this route param will give this component? Will give it the parameters coming in the route. And what this route data will give to the component? Will give, not the data coming from the user or anything. When you are defining your routes, if it is useful, you can define some data that you pass when the component is loaded. So if you recall, have a look here. When I defined this one, I passed in here this extra information. For example, it might be, this is a development environment, is prod environment, or is dev. And I might do something different based on that. This might not be very useful in all cases, but in some cases, you want to, if you wish to pass some information to the component, this is one way. There are many other ways to pass information to the component. At least for now, there are two ways. We will see more. The first way is you put it in the URL. Second way is you put it as an object in the route. There are two ways. We will see more ways to pass information to the component.
The data is
yeah.
The data we post through forms.
That will come later. Yeah, that is not this. No, it's not this. Yeah. The data you pass through forms, how do we get it in the component? Two-way binding. That's one way. Thank you. Yes. You do two-way binding, or you create controls. Remember forms, there are two styles, template-based forms and kind of model, no, template-based, this is where you do it two-way binding. What's the other way? No, it's not called model. I forgot the name. It's called driven, like basically you define the controls yourself. Sorry? No, model-driven is the template-based. Okay, let me see. Yes, you're right. Template-driven and model-driven. Okay. Yes. All right, let's go back to here. So, This one is not very useful, at least at this stage. But just be aware that when you are loading the component into the router outlet, you can pass to it some parameters, either through the URL or some kind of hard-coded object that was defined in the route itself. Yes, please.
Is the route config only done through an annotation, or we can actually manipulate it inside the...
Anything in here is manipulated through code.
That's why it might be useful, so it doesn't have to be hard-coded.
Yes, you're right, yes. By the way, like this, here we don't show this example. You can route the user by code as well. You can ask the router, please redirect the user to this URL. And I'm sure you can also attach information dynamically to the route. But at this stage, I myself didn't go there yet.
It's hard to programmatically tell it to go.
No, there is program.
There is something called location, that it injects and then you use .go. Never worked.
No, the router itself, I will figure it out. The router itself is, you can get an instance of the router and ask it, you can inject an instance of the router and ask it to go, it must be some method, redirect or something. Yes, you can explicitly talk to the router module.
Makes sense that you can.
No, I'm sure, I have seen it. I just can't recall the actual syntax. Okay, so let's go back. So now, if I want from my component, if I want to get access to the data that was passed to the URL, how do I do this? Do I go and say document.location and get the URL and chop it into pieces and try to grab what I need? I don't do that, okay? All I do, I just ask Angular, please give me this built-in object of type route param. That's it. It will be auto-injected into this component. You will get an object of type route param. Go to that object and say get and give it the name. What is this name? What is this ID here? This is the name you define in your route. Very important that they match. You see here, this is called ID, not here, ID. If you called it something else, let's say student ID or action ID or whatever it might be, then when you get it, you will also get it with the same name. Okay? So basically in here it's showing you a couple of things that are very useful. First of all, that there are some built-in objects that you can ask for, and they get injected by the Angular framework. And how do you get things injected? Go to the constructor, declare variables of the type that you want to be injected, and at runtime you will get those. In this case, for example, you will get the param object to get the parameters that were passed in the URL. You can also inject the route data. This is the data that was associated with the route when the routes were defined. And you can get that information as well. Okay? That is the idea of route. Is it? Yes, please. You had a question? Yes.
That class had a function, had a certain method.
Which class? This one?
The product detail component.
Yes, please.
So, if it has any sort of method, would that method have
access to this?
The product ID?
Yes, if you wish. Very good question. Very good question. There is the traditional way. I can come here and say, let's say product ID. Okay. Yeah. No. Sorry. This one is also already accessible. No. Sorry. I already making this accessible. I defined it and I store it. But if I want to keep this for future use, no problem. I can put it in here. Because I know the type. Route params. and I can store it for future use and make it available. Is this your question or? So other methods, if I have other methods, they can access this if I wish.
But the product ID should be by default accessible by other methods.
Yes, yes, they are. They are. So what I wanted to say, anything. The reason why I'm saying this is that the only way to get things injected is through the constructor. That's the only chance you get things injected. So when you get things injected, if you wish to keep them for other methods that will be used later when the user starts clicking things, then keep them. Keep them in a class level variables. If you are kind of lazy keeping them, or you don't want to write code to keep them, all you do is make this public. If you put this keyword public, then this will be accessible to other methods in this class. Okay. So either declare it and assign it inside the constructor, or if you want to keep the whole object, just declare it as public, and you don't need to waste your time creating a class level variable and assigning it in the constructor. Just put public, it will be accessible to other methods. Is clear so far? Okay. Is the routing clear? That's it. All right. So let me just go through this very quickly. Okay. I already explained. Just in here, please make sure you are referring to the route names. And if the route is expecting some parameters, pass them with the router link as an object. Don't forget your router outlet. This is where your components will be loaded when the user navigates to different link.
That's why you commented out the selector?
Yes, selector in this case, because this component will never be loaded as a root. Or
But it would be placed as undefined.
yes, no. What will happen is, sorry, this is not good. Let me. I should keep it. The reason why? Do you think? What is the reason I should keep it?
If you don't keep it, it will still work, but it will be used as undefined. The selector will be undefined.
The HTML.
Yeah.
The HTML you will have undefined.
Undefined, okay. But mainly the reason why it's a good idea to keep it, because I might want to put it in another component.
That's also.
Yeah. With that, not through the router. Not through the router. I want to put it in another component. For example, in here, let's say just for, let me just put here this backtick, and here is my backtick. Okay, just to have a multi-line template. All right, and then in here, suppose, not this one, sorry, not the, I want to do it the other way around. In here, in this component, I want to inject an instance of this component. Are you following? Okay, so what all I do, this one is expecting something called home. I give it something called home. Here it is. This one will be injected in any place with the tag home. And then I'll say in here, there's one more thing I need to provide. What is it? Anybody can help? One more thing. No, not this one. For this to work, one more thing I need to do. Directives. I need to tell Angular that this component depends on the home component. Yes. How do I do that? Directives. Directives. And I put it in an array and say, by the way, this product details component needs this for it to work. So, and this one now, because if when I load my component, this sub-component will also be loaded, and it will look in the template for a place where to hook itself. And what is the place this component will be looking for? the home. So we can try it and see.
Then you have to.
Okay, let me. Yeah, see here product details. I have two components. So here is home. The product details load the product details and the home. See here when I navigate here, it loads both. So that's why selector is also always very, very good to have, because it gives you the flexibility. You can load the component through the router in the router outlet, or you can load the component in another component that has that particular selector.
This, I think, reduces the quantity of writing in the template. You can make it components based.
Yes. No, it is more. It's not. The motivation is not reducing the. Yes, the motivation partially is reducing the complexity, but it's more reusability. If you have something, even a drop down, that you keep on duplicating in many, many places, make it a component, and that drop down knows how to populate itself. For example, drop down of semesters. It should just work by itself. Why should I repeat it in many? Why should I repeat loading these semesters and the code and the drop down and all this stuff in many places? I make it a component and put it in many other places. So reusability is the main driver. Of course, reducing complexity is another driver. But usually we should drive the division by, first of all, by cohesiveness, cohesive, keeping things cohesive, which means like the things that are inside the component are kind of related, functionally related. Second thing, we break it in a way we can reuse it. And of course, driving the complexity down as much as we can. Is clear? All right. So let me... All right. This is the how do I pass parameters. This is very important. When I define the route, I define the route with a placeholder for the parameter by putting colon and the name of the parameter. Now, as a component, I'm interested to receive, of course, I'm interested to receive that parameter because I will drive my behave based on that parameter. So, to do that, I inject an object of type route para and use that object to read the parameter that was passed to me. The name of the parameter I read, of course, must match the name that was defined in the routes. So you can see it's all nicely connected. Here is the final example, just to show you this in a very concrete way, in a real scenario. This is like, let's say something like Gmail. And this is your root component. When the component loads, this is what gets loaded. You have basically the home, and you have inbox, and you have the search. So this is what the main menu has. And then this is your router outlet. This is where things will be loaded as you go. In here, because this is my home, this is my root component, and this is my home component, they will get loaded. Of course, the root component will be loaded first, followed by the home component. Okay, so, and in this case, your routes will look something like this. If somebody goes to the routes, they will get the index component. If they go to a particular email, the email component will be loaded. And if they go to search, the search component will be loaded. These are my routes, and this is how the menu is generated. So I have one menu for the index, and one menu for the search, and underneath it I have an outlet where the component will be loaded. And just to remind you, this is how the link is constructed. I have an anchor. Instead of using the href, I use the router link and bind it with a particular route, and bind it with a particular route. That is the idea. And this in here it is an array, and the reason why it is an array because I can pass some parameters if the route needs such parameters. And from the router config, this router link will be converted to an href, and it will be the path that is specified in the path of the route that is referenced in the router link. That's basically how it works. And this will be translated to something like this on your page. And of course, the advantage is you have the freedom now to change this. Anytime you can change it, no problem. Application will not be affected in any way as long as you keep the name of the route the same. You can change the route's path as you wish. Now, some routes expect parameters. I explained what's going on there. Now, when you are expecting parameter, this is an example. This is similar to your actions table. In your actions table, you will have something like this, where you have a ng4. In this case, for example, for each email in emails, I will have a link to see if the user clicks on the subject. Can you see here? If the user clicks on the subject, then they will be routed to the route named email, and the email ID will be passed as a parameter to that route. So you can see it will be something like this. So router link, this is the name of my route, and this is the route param that will be passed to this route. And finally, here is how it looks. So this will be passed to this parameter to construct the whole URL and will be assigned to the href. So that is basically the end-to-end idea. Okay, this is the basic of routing. If you apply this and practice it, it will become much clearer. Then once you are comfortable with this, and if you wish, you can go deeper into sub-routes and auxiliary routes. And these are nicely explained in this video and in these slides. Okay, should we take a break or? Okay, so we take a small break, 10 minutes. So
classes with the module and the component. We have classes with the module, which is shared for the whole application, and we have classes in the component. The component itself is class and module.
Yes, so a component is a class, of course. Component is a class. And because that class is in a separate file, so it is a module that you need to export so you can import it somewhere else. So basically the JavaScript, the concept of a module, if you want to be a little bit more mechanical, is that you have some file that has some functionality. It could be function, it could be class, it could be even variables. And you want to make them accessible in another file. How can you make it accessible in another file? This is where the concept of module comes in. You have to export them from one file to be able to import them in the other.
I mean the classes in the component itself just for define the properties and the methods for event handling.
Yes, and the annotation defines the visual look and feel.
You should not do the business logic in the component.
Yes, very good. Yes, the components should basically have two things: the visual aspect, the visual look and feel of the component, and it should have the event handling. But the actual work, when the event happens, you can think of the component class as a client-side controller. It just coordinates, but handles the heavy work to the services. So service in Angular is just a class that will do the actual work. So let me give you an example, concrete example. So these examples, they are almost ready. I'll be pushing them today. So let me first run it, and then explain what's going on and explain the concept of a service and how it works in Angular. So let me run it first. Here is my run. So very, very simple application. All it does, it goes ahead and loads some list of people. And then beside each one, there is a button, for example, it says hello. And when I click it, I get an alert box saying, you said hello to that person, Ali, for example. If I click some other one, I get, you said hello to Mariam. Okay? So that's what this application is doing. So you can see that basically, definitely I need to get this list of names. In real life, you might need to go to the server side and fetch them from some REST service. But in here also we are fetching them from some REST service, but it is just a file. Although in real life will be a REST service from the server side. So this interacting with the server side, the reading and writing data should not be in the component. It should be outside the component. Plus, this information, this list of names, for example, could be used by multiple components. In your homework, you have the list of students. I'm sure it will be used by the student component to get you the list, and also by the action component to do what? To fill up the dropdown. Remember, you have the dropdown to jump from one student to another, go next, or before, or you can go to a particular student by dropping down. So that logic of getting the students from the server side or from local storage, from whatever it might be, the data source, should not be, as a good practice, it should not be in the component itself. It should be in a separate class that does the actual business logic and data read and writes to any data source. Could be a local data source, or later on you will make it a real REST service. So such classes that do the actual work and do the reading and the writing, they act like repositories. We call them in Angular, we call them services. So what is a service? Is nothing but a class. But this class has a special annotation. So here is the class that is responsible of, here is the class responsible of getting the list of students. Or here the list of people. So let me go through it. First of all, here I just create a class. This class I call it people service. You can call it whatever, student service. You can just call it student repository, whatever. But maybe service is a good name as a postfix of the name of the class. Then it has a constructor. And then what I'm doing here, somebody can tell me?
Requesting inject.
Yes, I'm asking Angular to inject for me this built-in class called an instance of this built-in class called HTTP. What do you think this built-in class will allow me to do?
Ajax.
Yes, Ajax. Okay, so Angular has very powerful Ajax, HTTP or a REST service client. So on the client side, you can interact with the REST services using this HTTP service. So HTTP in here, it's not a component. It doesn't have any visual appearance. It is a class that does some work for you. So Angular can inject for you built-in services, and your class that you make, you can also make it injectable. How do I make a class injectable in other components? By adding this annotation to it. Injectable. And this injectable is coming from the core Angular 2 library. So I import the injectable class and use it to annotate my service. Okay? Now, when my service is created, for my service to work, it depends on another service that is built in Angular, and this service is called HTTP. And as you can see, I added this public here. Why did I add this public?
So you don't have to use.
Yes, so I can make this accessible in the whole class. If I don't put this, then this HTTP will not be visible outside the constructor.
Unless you have a variable.
Yes, unless if I want, I can put here. If you wish, you can do it this way, but too much unnecessary work. And in here, sorry, HTTP. And in here, you know what I am trying to do. In here, you will do this dot HTTP equal HTTP. So this way is fine. So you get it because the constructor is your only chance to do injection. You cannot do injection in another methods other than the constructor in the Angular so far. So instead of doing this 2 extra lines, no need. You just remove them. And if you really want to make this injected object visible or accessible in the whole class, all you do, make it public. And that's it. This is now accessible in all other methods. Okay, so HTTP is a built-in service, very, very important service. What it does, it has get and post and other methods, but the get and post, this is what we need so far. So get, and I give it the URL. In here, it's a dummy URL. This URL is pointing to a file, but in real life, it will be pointing to a server-side REST service. When the reply comes back, I transform it to JSON. So far, they don't transform it for you to JSON object. You explicitly change it to a JSON object. Basically, when you get it, you transform it to a JSON service by calling this map. Whatever the response you got, go ahead and make it a JSON object, and then return the JSON object. Is clear what this is doing? Okay. This is returning. What is it returning?
Object students as a JSON.
Are you sure?
It's returning an array of people.
Are you sure it's turning an array of people?
It's returning a subscription. Observable.
Yes, it's similar to promise. This is an asynchronous call. This is not synchronous. So when you call what we have seen so far, when you call an asynchronous function, so far what does it return to you? In your homework too. What does it return? A promise. What is a promise? A future value that eventually it will be fulfilled and you get the list of people, or it will be rejected and you get an exception. So it's a future value. So in here, the caller of this will not block and wait for this to come, for this list of people to come. This method returns immediately, but it does not return a promise. Promise is something of the past. People are moving on. We just learned promise and they want us to forget about them. So Angular really brought along another conceptualization or another programming abstraction called Observable. It's not really an innovation in Angular. Surprisingly, this innovation came from Microsoft. It's a they are the inventors of this idea of observable. And it's deeply supported in .NET. And this idea is now making its way out of .NET to other platforms. Like in Java, they are trying to, at least third-party libraries, trying to support this idea of observable. JavaScript is also trying to do it. In JavaScript 2016, the next version will have native support of observable. So this observable will be kind of the next step after promise. I will explain it in more details shortly, but for now is enough. Like you already, familiar with the concept of promise. So this one, it's returning an observable. An observable is similar to promise, but there are differences. I will explain them shortly. But definitely, it's not returning the list of people. No, it's not returning them yet. Eventually, in the future, you will get them. Okay? So, that's it. This is a service. Now, for me to use it, of course, I can always go and say create an object and say equal new instance and then call this method. I can do that, of course. But this is not recommended. Angular and all other platforms, Java, .NET, they all going towards this concept of dependency injection. If you depend on something, don't create it yourself. Let the framework give you an instance at a runtime. And this is very, very important for testability. When you want to test, for testing, for unit testing, sometimes you can pass what is known as mock objects. An object that looks like the real object. And you can ensure some kind of isolation. So when in unit testing, it's very, very important to have each unit test is isolated from other unit tests. What I mean by this, for example, let's say I have a component called database that reads and writes to a database. So instead of using a real component that talks to a database during testing, I can use a mock component that just receives the parameter and do console out of the parameter. It does not go to the database and save it. So in this scenario, if I am testing a particular method, if there is an error, it's coming from that method, not from the database component. Because database components, I am passing a mock object. What I want to say here is this dependency injection is a very important pattern to improve or to make it easier to do testing. Now, I have this service. How do I make this service available to components? So I have this service, which is basically a class. There's nothing special about it except this annotation. So I have this service. How do I make it available to the rest of the application? There are two scenarios. Do I want it to make it available to all the components, or do I want to make it available to one particular component? Depend on the scenario. So if I want to make this service available to all the components, all I need to do, I go to the root component where I bootstrap, where I start, when I launch the application, I will say, please go ahead, launch my root component, which is called app. And by the way, be aware that I have a service called people service. If somebody asks for it, don't tell them I don't know about it. I'm letting you know that there is a people service. Give it to whomever asks for it. So now in this app, if I want a people service, all I need to do, just in the constructor, declare an object of type people service. That's it. Don't do any new. Can you see here? Is there any new or anything? There is no new or nothing. Just take it and start using it. Don't create it yourself. That is the idea of dependency injection. So, and then here, I'm getting here get people, okay? This is the method that is returning to me an observable. And instead of doing then, remember the promise, the way we deal with promises, is that when I get a promise, I listen to fulfill the rejected using the then, if you remember. In the observable that I will be explaining next, I listen to fulfillment of this observable or some values coming from this observable through the method called subscribe. And I'll explain why these things have significantly changed. So in here, all I'm doing is I'm subscribing, if everything goes okay, I get the people's list coming back from this method, and I place it in this variable called people. Otherwise, I might put some error message, whatever, call failed, for example. And so basically subscribe takes three functions. One is to process what has been received. Another one is to deal with errors. And another one is to deal with completed. And I will explain this in more detail. All right? That's it. This is how I create a service and inject it. So to summarize very quickly, a service is nothing but a class, very normal class, has nothing special about it. This class, it does the computation logic. It talks to data sources. It reads and writes to data sources. And then these classes are typically injectable. You can, any component can ask for it. So when this component asks for such classes, such service classes, they don't need to instantiate themselves. Instead, they get injected into the component. So how to get it injected? Two ways. If you want to make it injectable throughout all the components, and to have a singleton, you are familiar with the singleton pattern? One instance in the whole application. You want one instance of this service in the whole application. Imagine that this service, imagine this service here. I have some, maybe I have here something called people, which is an array. Or let's not call it people, departments. For example, so here, and then in this department, I might want to initialize it with some stuff. Department equal, well, let me make it a string. Don't forget here that this is very important, otherwise it will not recognize it. So in here I will say CSE alright. So this service class, it has some state. It remembers some of the data. Okay? And it's a good idea not to have too many copies of this class. One instance is enough for the whole application. So to ensure one instance, to ensure that there is one and only one instance in the whole application, what I can do is I can define the class, annotate it as injectable, and then go and make the application aware of it. How do I make the application aware of this class or this service? By going in the bootstrap. And then any component can get an instance of this service by declaring an object of type people service in the construction of the component. Is this clear? So this will ensure that you have one instance in the whole application. Now, if you think that this service is not really relevant for the whole application, so maybe you don't need to inject it here, or you don't need to make the whole application aware of it. What you can do instead, you can go to the component that needs it, and in the provider's property, put it in there.
But each time a provider requests for it to create a new object?
Yes, this is my understanding. Yes. My understanding so far, I have not played with it deeply. My understanding so far in terms of differences, if you inject it this is not really injecting, it's kind of making the application aware of it at the bootstrap time, then it is a singleton. It's only visible, it's one instance in the whole application. And this is very important if that service holds some state that is shared across the components. Okay? Now, for example, what I mean by state, for example, how many components were loaded or how many times the component was loaded. As an example, this is an example state. Whenever a component gets loaded, it goes to that service and increments a counter, as an example. So in here, you need to have a singleton. So you keep one object in the whole app. Now, my understanding so far, if you only make it available in the component, so it makes sense that each component will have its own instance. It will not be a singleton. That's my understanding. We need to verify this. But at least let's take it like this. This is the difference. If you kind of define it, or you make the application aware of it at the bootstrap time, then it is singleton. This one I'm sure of. It is singleton available across the whole application to all components and visible to all components. Or if you don't want singleton, if you want each component to have its own instance, then put it in the provider property of that component. Is clear? That's basically the concept of a service. Now, next thing we need to understand, let me see if I missed anything. Yeah, that's it. So, service is nothing but a class that has the annotation injectable. Special in here, if you just put it in here, sorry, here it is. If you just put it in the provider, I have tried this, you don't need to add that annotation. It will work without the annotation injectable. But if you put it in here, when the application bootstraps, then if you don't put that annotation at injectable, it doesn't work according to my tests. But anyway, I hope you understand now the difference between the two. Okay, this is the
sorry, each component that needs to be injected at has to also import it, right?
Yes, that is for sure, yes. So importing is very, very different than injecting. Very different. So importing is just to make that class visible in terms of at development time. Okay? So injection is something that will happen at a runtime. So the importing is more something at compile time. You can, like if you don't import the class, then you cannot get the IntelliSense. You cannot. Your component will not be able to deal with that class. But the injection is something at a runtime. At a runtime, your component will receive an instance of the class, of the object that you asked the framework to inject for you.
Even if you are having something as singleton, we still have to import them.
Okay, importing. So in here it is. So if I don't put, what I want to say is, this is something really, really different. Here at a runtime, the AngularJS or the Angular tool, when the application starts, it will create an instance of people service and keep it. Whoever asks for it through the constructor, they will get an instance. Okay? Now, in here, at compile time, for this application to compile, I must import this. Otherwise, this is not visible. It does not know what you are talking about. So it needs the definition. What do you mean by people service? You say, oh, don't worry about it. This people service is really, I defined it in this file called people service.
Import is basically for compilations. Even if we don't import it in the compiler, we try to manage it. No, you will need it at runtime as well. You need it at runtime. Both.
System.js is making use of it.
Yes, System.js also making use of it. Yes, but it's still, what I want to say is very, very different than the injection. Here you're just importing the definition. But what is the definition of people service? But injection you get in an instance. So, and the framework on your behalf creates an instance and give it to you. And if it is Singleton, it's created at the start or maybe at the first request and give you that instance. And then whoever asks for it, they will get that same instance. Okay?
So when we use providers to inject?
No, not providers to inject. No. The injection happens through the constructor. But anything injectable, anything that you want to inject, it must be either already listed in the providers or in the bootstrap. That's it. Otherwise, you cannot inject it. Is clear? Yeah. So, for example, if I remove this from here and it is not in the bootstrap, it's not in the bootstrap, so maybe this will fail. No, it didn't fail. No, it's still running. Yes, it failed. Okay. You see, it failed because everything is there, but I didn't put it in the bootstrap and I didn't put it in the provider. So if we put it here, in here you will see it's taking a little bit longer because it's compiling in the browser. So it's, see here it came here. Or if I remove it from here, go back, you will see that it will fail because it does not know, it's not aware of that service. So I want to make it component specific. So I'm injecting it here. Okay, now it should work. Okay, now it should work. Now let me show you one more thing. In this case, the injectable is not required, according to my tests so far. So this annotation in this case is not really required. It's compiling, that's why it's taking this long. It's compiling on the browser. It's taking too long than required. Maybe you're right. There is some error. Yeah, there is. Yes, alright. Yes, in this case I'm wrong. This is always required. I'm not sure why. Okay, خلاص. This all makes more sense. Okay. So to summarize, the services must have this annotation at injectable, otherwise you cannot inject it. So see here, it's coming back happily. There is one more feature in here. In this example has a couple of features. I showed you the concept of a service and how to make it injectable. You can inject it you can basically make it injectable either by making the application aware of it at the bootstrap time or in the provider property of the component. Okay. One more thing I want to show you is in the same exact example. Here it is. What I have here, I have this app. And this app, as you can see, this is the template. Okay? And this template, it has a header, and it has a placeholder for another component. Can you see it? A placeholder for another component. And this component is called person. So this is a list of people, and each row is in its own component. Are you following? Okay? And This is basically the placeholder where the components will be injected. So what I'm doing here, I'm going for each person in people that I received from the service. And now what I'm doing, I am passing the name to the name parameter of the person component. So a component can be made up or can include other components. Now, the parent component can pass parameters to the child component. And also the child component can raise events to the parent component. This is a very important concept. We have not seen it so far, but very important how that components, they can interact with each other. And the typical interaction is the parent passes some parameters to the child, and the child raises events to the parent. Of course, when you raise events, you can also pass data through the event. All right, so let us have a look how this person component looks like. Here is the person component. So it's a class called the person. And you can see here in the component annotation, we have two more properties. One is called inputs and one is called outputs. And it is an array, so it can be multiple inputs and multiple outputs.
So this is the shared component of...
Yes, yes. So here in this scenario, the parent component is kind of, let's say, a table. And each row is a child component. Okay? So this is to reduce complexity, also to make it more and more modular. And maybe this person, you can use it in different places in your application. Okay, so here the communication is very explicit. Either the input is coming through the input and the output is going through the output. And here you give this a name. It's an array of names. Okay? And then, for example, here this component expects an input called name. And it raises an event called hello. So it receives an input called name. And it raises an event called hello. So let's see how this is used and come back. So because it is expecting an input called name, so I do one-way binding. Remember the one-way binding? I am binding this with this parameter. So if this one changes, this will also change automatically. So it's a one-way binding between the parent and the child. Now, the output is an event. Remember how do we respond to events? By putting the event name between parentheses. And hello is a custom event. Coming from where? From the child. Okay? Now, when these events happen, I will call this method onSayHello. Where is this method defined? In the component. No, not in person. In here, downstairs, down here. Here is my onSayHello, and I'm passing the event as a parameter. This event is what I received from the child. Okay? So I will go say hello. This is what I received from the child, and I'm saying you said hello to whatever the parameter I'm receiving from the child. So this is very important to understand the communication between the parent and the child. It is explicit through input-output. Typically, the parent is passing some input to the child through one-way binding, and the child is a raising event to the parent, and the parent can respond to those events by using the same syntax as built-in event, like click and mouse up and all those events that you have seen before. Same way you deal with them same way you deal with custom events. You deal with custom events, same way you deal with built-in events, DOM events. And custom properties, you deal with them the same way as built-in properties. Okay, so now the last thing I want to show you is just how we raise events. This one is clear. The name is just coming from the input, so we can use it immediately in our child. No problem. It's coming from the parent. In here, we have a button. When the button is clicked, what I do here, I have an event emitter. It's like some kind of event generator. And I'll say, please give me another event I can throw to the parent. So I'll say, event emitter, next. And I'm passing, this is what I'm passing in the event parameter. I'm passing the name that was clicked. So the event knows which name was clicked. Same, like for example, when you click somewhere on the page, the click event can give you the X and Y coordinates or where the mouse was clicked. Or it can give you even which element was clicked. So in here, same thing. When the event happens, you can pass some parameter to the recipient of the event. And very simple. I create an event emitter, and you ask it, please give me an event to pass back to the parent. So this is the communication between the parent and the child. Yes, please.
For example, in our case, it's a very simple event. And so we can have the complete event inside the child.
So, sorry,
if we don't emit the event,
yeah.
we just try to handle it within the child, just have a let pop.
Yes, but this is not reusable if you handle it here, because maybe the way you handle it, the parent knows better.
So if we have more properties that we have to work with for the event, we should be using parent. If something that is containable within the child, something that is very specific to person, for example.
Yeah, if it is. For example, let's say this is different. Let's say a little bit more realistic example. A little bit more realistic. Let's say this is a drop down, and I raise to you the person change event. Okay. Now, depending where that drop down is used, maybe if it is used in the login, for example, it might. As a parent, I will go and get the rights of that person. If it is used in actions, I will go and get the actions of that person you selected. So I cannot put the event handling in the child because the behave depends on the host, the parent that hosting that child. So that's why of course you can do handling here. But it's not very generic, it's not reusable. Remember that component should be made as reusable as possible. And this mechanism is the best way to ensure reusability. It will become more clear if you have more realistic example, like some kind of drop-down. Let's just take a small example. Let's say you have semester. Remember semester drop-down? I might use it in the student component, and if I change the semester, I get different lists of students. I use the same semester component, I use it in the actions component. Whenever I change the action, I get a different actions. Sorry, whenever I change the semester, I get different actions. Same component, but the response to the event depends on the parent. That's why we don't handle it in the child, we just raise an event. Say, oh, by the way, the semester have changed. I can give you the old semester, I can give you the new one. As a parameter that's coming with the event. Okay, so also you have to think what you will pass in the event, because it's very important. The recipient needs to get enough information to make some action. Okay, that is the reason. All right, so let's move on. These are services. Dependency injection, we already seen it. Very important, very widely used design pattern that you don't create objects yourself, get the framework to do it, and they will inject for you the object at a runtime. So we already seen this. Now, reactive programming. This is very important trend in development in general, but in JavaScript in particular. This is a new, really new trend. It is mainly came from, as I mentioned, from .NET, Microsoft Innovation, that is now making its way to other platforms. And it will be part of Java natively supported. But now, for now, there are libraries. So the trend now is that people think of some ideas, they go through standardization, that will take some time. And when it's standardized, the browsers will take their time to implement them. But we don't need to wait all that time. There are libraries that can give you that behave now. And in the future, when the browser becomes capable of doing it, you throw that library and you rely on the native support in the browser. That is the idea. Okay, so in a reactive program, it is all about listening to changes and propagating those changes and reacting to them. That is the idea of reactive programming. So before going deeper into it, let's just take a look at some concept that you're already familiar with. So first of all, you have the concept of iterator. I'm sure you have seen some kind of, let's say, an array or a list. You can make it as an iterator, and an iterator, you create an iterator, let's say, over an array, and then you ask the iterator, give me the next value, and you keep pulling. You are pulling values from the iterator, and you're doing some action based on that value. That is the concept of iterator. In iterator, you, as the consumer, let's say the consumer, is the one that have control. And it is the one that is pulling the values and acting on them. Now, observable is the other way around. The source is the one that is pushing the value to. This is a major shift. So in here, in a web development, there is, as an example, there is a major standard. Hopefully, some of you will cover it a little bit more in your presentation, which is a WebSocket. So traditionally, with HTTP, it's usually the client that takes the initiative. Client says, get, post, delete, and so on. So in many scenarios, that is fine. But in some scenarios, we want the other way around. Let's say the famous scenario is you are watching some stock market and you want to get updates about the prices or currencies. Currencies going up and down. You have some saving you want to send somewhere and you are waiting for that special spike. So one way to do it, every time you refresh, or you program the browser to say every few seconds or minutes it will go to the server. So this will generate, of course, traffic on the server. It will generate more load on the network and so on. It would have been much easier if you just kind of subscribe. And if there is any new changes, they will be pushed to you. Okay. Same thing, for example, Al Jazeera. I'm sure currently they just have in the header some kind of refresh parameter and the page auto-refreshes from time to time. So, but we are now moving, thanks to this web standard called WebSocket. It's a two-way communication. The browser, the server can initiate and push changes to the client. Okay? And so the iterator is similar, the observable, an observable is similar to iterator. There's a concept of values that come over time. But this time is not the consumer that controls next. It is the provider that whenever there is a new values, they get pushed to the consumer. Okay? So to give you this Some of you might already familiar with the observer pattern. I'm sure some of you have seen it. What is the observer pattern? How does it work? What is the idea of the observer pattern? So we have some data source. And what the consumers do?
We observe it.
Yeah, they subscribe to it. They subscribe to it. And then whenever the data source, whenever there is some update, it gets pushed to the subscribers. Okay? So for example, Al Jazeera or CNN or all these channels, news channels, there are two ways. You can always do iterator, go and refresh the page whenever you want, or you subscribe to a service. Could be SMS service or other services. You subscribe, and whenever there is some important news, and you can subscribe and say what type of news you're interested in. And when there is such news, what they do? They push it to you. So this is the observer pattern. So you are observing some data coming in the future, and it will be pushed to you. This is the idea of the observer pattern. And this is the idea, so the news items that are coming are basically called observables. Okay? So let me go back to the same example. So in here's my people service. So in the old days, when we deal with the REST services, we basically usually return a promise. Remember in your homework too? This will return a promise. So instead of returning a promise, we will be returning an observable. What's an observable mean? What you can do with an observable, you can subscribe to it. You can say, I want to subscribe, which means whenever there is an update from this service, I will keep getting them. And of course, I can unsubscribe if I wish. So it's a very kind of different model than promise. What is the difference between a promise and an observable? Just from this discussion so far.
The observable would be passive, and the promise would be active. In terms of a promise would be just a response to a question, but the other way around is just whenever something changes.
But both of them, once you initiate the request, both of them are kind of, we're waiting for the reply to come. So both of them are asynchronous, and both of them will happen in the future.
One of them happens once, the other one can't happen more than once.
Thank you very much. That's it. With a promise, how many values you will get? One, and only one. And once you initiate the request, you cannot cancel it with the promise. Khalas. Once you initiate the request, you cannot cancel it. With the subscription, you receive multiple over time. You can receive multiple over time, and you can unsubscribe. This is the major difference.
So
Yes,
if we subscribe to a method that returns an array.
Yeah. Not an array. It's a values over time. So when you subscribe to Al Jazeera News, do you receive all the alerts in one go, or do you receive them over time? You receive them over time. So basically, you can think of it as a promise with multiple values that will come in the future. So promise is one value. Once it's fulfilled, khalas, that's it, finish. And an observable is something that promises you more values to come in the future. So keep listening there, and they will come.
For example, in this example, we are having an Ajax with people.json. If in future we add some values to people.json.
Yes, they will be picked up. Of course, the server side also need to have the ability to push changes using some kind of WebSocket. So the server side, of course, also is responsible. So imagine, let's say these are the people that we need. Let's say I am the debt collector. Like some company, they have people that they need to follow up to get their money from them. And of course, this list is dynamic. So me, when I come to work, I just open my application and I see the list of people that I have to call or drive to them or send them some bad guys to squeeze from them whatever they need to pay, whatever I need to do. Okay? So there are two ways. I can every time refresh to see the latest list, or I just subscribe to this kind of people to chase. And whenever there is some new people to chase, they will just appear. You see the kind of applications. Let's say you have actions, tasks, your tasks list. Here's your tasks list. You say, okay, your manager assigned you something. Oh, sorry, I forgot to refresh. Or your application needs to be programmed every 5 minutes. Go and refresh. You see now the programming model is now different. You have some values that will be pushed to you continuously in the future, and you need to react to them. And that's why we call it reactive programming. Is clear? Okay. Another way to look at observable, they look like arrays, isn't it? They look like an array because it's a values that will come over time. It's a stream of values that will come. What is the difference between an observable and an array?
Array, you know the length.
Array, you know the length. Why?
Because we have the values.
It is synchronous. These are synchronous values. At certain time you have them. Boom, here is the values. But observable, you can think of it as an array, but it is asynchronous.
Dynamic.
Dynamic array, asynchronous. It will kind of be complete over time. Now, yes, basically, for example, the list of people you will deal with to chase to get the company money. They didn't pay their invoices. So, in the morning you'll get 2. 10 o'clock you'll get another 4. 12 you will get another 5. By 3 p.m., that's the time business will close, you will get the full array.
But for some cases, it won't stop.
That is fine. Yeah, that array is continuous. But what I want to say, it looks like an array. So reactive programming, it builds with this observable in a similar way you deal with arrays. You can do maps. You know, with arrays you can do map. You can transform the array. You can do filter. You can do concat. All these operations you can do on arrays, you can do on observables. So, all the operations you can do on promises, you can connect them and compose them. You can compose observables. All operations you can do with arrays, you can also apply them to observable. So you have now very powerful mechanism. This is the last thing I will show you now, is small example of, here is the last example. Here, run. But now you have everything for your homework. We covered everything. There are a little bit more details. This is an example of YouTube service. I will post in this example. And this YouTube service, here this text box becomes an observable. As I type values, it raises a new values to my program. You can think of observable is not just your stock exchange pushing you the latest values of your stocks. Okay? Observable is a programming abstraction that you can apply in many scenarios. For example, in here, this text box, I am treating it as an observable. As values keep coming, as the user types, you basically observe that text box, and as they type, you go and get some, for example, in here, I'll do Angular. See, as I type, these things change. Okay? And I'm calling a service, I'm subscribing to it. So, the way this observable concept as a programming abstraction is a really profoundly changing the way web application will be built moving forward. So Angular has this observable as a very, very important component. Oh, sorry, very important concept in the framework. So, you know, forms, you can think of forms as observables. You can observe the whole form. If anything changed, you can reapply the validation. Or maybe if anything changed, you can save back to the server side. And you don't provide any save button. A lot of services around these days, there is no save button. As you just work, they just auto-save and auto-push things to the server side. So by very simple code, I can show you in the slides and through the examples, you can make the whole form an observable, and you observe the whole form. You're basically watching over it, and whenever something changes, you can apply validation, you can push the changes to the server side and so on. So it's a whole lot of applications will be improved the way you did using observables. And there is a clear, even in the slides, there is clear evidence. Maybe the code shrinks by at least a third compared to not using observables. Like, for example, using event handlers or using promises. You need to do a lot more work to achieve the same scenarios. In the slide, you will see this example without using observables and the same example with observables. It's a major difference. Okay? And you might think this is very complicated, but the code behind it is very, very simple. Like just this last here, code behind it. Here is the code behind it. Here it is. That's it. This is what it's doing. This is what that whole thing is doing, these 3 lines. This is the search box. Value changes is an observable provided by this search box. I don't react immediately. I'll wait for 150 milliseconds because I don't want to react as the user types. I wait between a little bit. And then I pass this, whatever I got from this search box, I pass it to the search method of YouTube. And that's it. When I get the results, when I get these results, I put them in results, and I pass them here. I pass them here, and I say, by the way, these results are observables. Be aware that these results can change anytime. And by doing this filter, that's pipe here called async, this, although it's not an array, but you can treat it as an array. Okay, it is an observable, but it is an array that is kind of asynchronous, and values can keep coming to that array at runtime. So I think I leave you with this. This is very, very important. So definitely one of you will look into this more closely in your research paper. I'll be providing some papers on this, so to help us all go a bit deeper into it. And this whole area is called reactive programming. Reactive programming. It's not specific to JavaScript or Angular. In fact, JavaScript and Angular are catching up. This is already in .NET, already in Java, and already in other platforms. Okay, thank you very much, and I will see you next week. I am here if you have any questions or discussion. And also during the week, you feel welcome to email me. We can meet, discuss if you have concerns or issues.